We are given a Bernoulli single server queuing process, Q, with the probability of a service in a time interval being 0.1 and the probability of arrival in a time interval being 0.2. So first thing to note is that there's more arrivals than services, and so this queue would never settle down. However, we're only asked about the probability of the queue in 2 time frames into the future being 1, given it's 1 now. When we look at this problem, we have to think, well, what might we use? What do we know that could be helpful? And the answer really is the Markov property, meaning that if we look 2 steps into the future and condition on 1 step and no steps into the future, whatever it was at no steps into the future, i.e. right now, is irrelevant, because the Markov property says that wherever you are, say 1 step in the future, the next step does not depend on the past. And so we're going to use that, but what we're going to do immediately is we're going to use total probability with a conditional probability measure. So that conditional probability measure is, say, p bar, which is the probability of the queue given that the queue at the current time is equal to 1. And so using total probability with this p bar measure, we have that p bar of qt plus 2 delta being equal to 1 is equal to p of t plus 2 delta being equal to 1, given that q of t is equal to 1. And then this total probability would be that that's equal to p bar qt plus 2 delta being equal to 1, given qt plus delta is equal to 0 times p bar qt plus delta being equal to 0 plus p bar qt plus 2 delta being equal to 1, given that qt plus delta is equal to 1 times p bar qt plus delta being equal to 1, plus finally p bar qt plus 2 delta being equal to 1, given qt plus delta is equal to 2 times p bar q plus delta being equal to 2. Now, if we convert back and get rid of these bars, we have that p q plus 2 delta being equal to 1, given qt plus delta is equal to 0 and qt is equal to 1, times p qt plus delta is equal to 0, given qt is equal to 1. So we've just substituted in for p bar, and we noted that, well, if you condition p bar on something, it's just a double conditioning. So conditioning p bar with these events qt plus delta is equal to 0 is the same as conditioning p with qt plus delta is equal to 0 and qt is equal to 1. So we continue then and we add plus p qt plus 2 delta equal to 1, given qt plus delta is equal to 1 and qt is equal to 1, times the probability that qt plus delta is equal to 1, given qt is equal to 1, plus p of qt plus 2 delta is equal to 1, given qt plus delta is equal to 2 and qt is equal to 1, times p of qt plus delta is equal to 2, given qt is equal to 1. And so by the Markov property, we can just get rid of the conditioning on the qt is equal to 1 in all the terms. And so we would then have p qt plus 2 delta is equal to 1, given qt plus delta is equal to 0, times p qt plus delta is equal to 0, given qt is equal to 1, plus probability qt plus 2 delta is equal to 1, given qt plus delta is equal to 1, times p qt plus delta is equal to 1, given qt is equal to 1, plus p of qt plus 2 delta is equal to 1, given qt plus delta is equal to 2, times p qt plus delta is equal to 2, given qt is equal to 1. And then we can just use a shorthand about how it changes. So p qt plus 2 delta is equal to 1, given qt plus delta is equal to 0, is a change from 0 to 1. So you could just write that as a probability of going from 0 to 1. That's multiplied then by the probability of going from 1 to 0, i.e. qt being 1 and qt plus delta being equal to 0. So we have the probability going from 0 to 1 times the probability of 1 going to 0, then plus the probability of going from 1 to 1 staying the same, times the probability of going to 1 to 1, plus the probability of going from 2 to 1 times the probability of going 1 to 2. And now we can write these formulas in. So we know that the probability of going from 0 to 1, since services come before arrivals, is just PA. And the probability of going from 1 to 0 is PS times 1 minus PA. So to go to 0 to 1, it doesn't matter if you have a service because it would be discarded, and so that's why it's just PA. But to go from 1 to 0, you need to have a service and no arrival. Otherwise, if there was arrival, you would stay at 1. And then we add the probability of staying at 1 squared. And so the probability of staying at 1 is either the probability of no arrival and no service, i.e. 1 minus PA times 1 minus PS, or i.e. plus both an arrival and a service, PA times PS, and then we have to square that. And the probability of going from 2 to 1 and 1 to 2, well, the probability of going to 2 to 1 is PS times 1 minus PA. You need a service and no arrival. And the probability of going from 1 to 2 is PA times 1 minus PS. You need arrival and no service. We can just now simply plug those values in and we get 0.02 times 0.8 plus 0.72 plus 0.02 squared plus 0.1 times 0.8 times 0.2 times 0.9. Putting that all together and we get 0.578.